Hi, good afternoon. I'm Robert. I'm a big data specialist based out of Amsterdam. I'm here today together with Ashok. He's from the Bay Area, customer engineer working in the Bay Area. So we're going to take you today through migrating data warehouses. If you have like a question that really can't wait until the end, just put up your hand. We're going to do this in 3 sections. So the first 10, 15 minutes, we're going to go through a little bit of the reasoning why. Then we're going to look at some reference architectures. After we've done that, we will move on to a demo for about 20 minutes and actually look at some of the work involved. And then we will come on to the more like let's say the logistics of it. So we can go through the technology, but after that, what does it actually look like to actually get all the parties involved actually committed and working towards the goal of this data warehouse migration? So to start us off, let's have a little think about a data warehouse and what it actually is. So often, when we're talking about data warehouses, when I'm working with customers, and I should say previous to joining Google myself, I was a customer. I worked for a company as a lead data engineer, and I moved a data warehouse to BigQuery. So I have some hands-on experience with this stuff as well. And when we were doing that, often when I was talking to some of the people in the business, the use case that was presented was the data warehouse. Well, the data warehouse isn't a use case. It's something that enables use cases. So it's the underlying platform. And that was really key to kind of get in everyone's minds to say, look, there's a reason why we're doing this. And let's understand what that reason is, because then we can actually think about what we want to do. Because there might be some stuff we want to migrate. There might be some workloads that we no longer want to take with us. But what are the use cases we're trying to fulfill? Now, we tried to split this up into 4 different types of use cases. I'm going to walk through them now. So here they all are: operational reporting, ad hoc reporting, Adhoc Analysis, and operationalized insight. So we'll take through one by one. So the first one, operational reporting. This is your, the common, typical dashboarding area. So, I'm in the business, and I want a dashboard to actually see, how much inventory do I have left? How are the sales doing this month? Those dashboards, the queries get built out, the dashboard gets put in place. So what are some of the concerns that we might want to think about if we're going to migrate some of these workloads? Or what are some of the concerns that are typically associated with this particular use case? Well, one is obviously data quality. If the data quality is not good, those numbers aren't good. Data timeliness, that's a big thing. I mean, often when you're working on-premise with your data warehouse team, especially if you're coming from, let's say, more legacy setup, there's a lot of batch processes that run at night. If one of those batch processes fails, then the question is everything going to be there in time to get the numbers out the next day? I hit that question so many times in the past. And then reliability, which, is obviously comes into the other 2 as well. But if you don't have good reliability with your system, then you're trying to, the other 2 are very difficult to deliver on, let's say. So the next one is ad hoc reporting. So typically, with the operational reporting, that is the thing that everyone says, I want those numbers, I want those dashboards available. If they're not there, you probably have some, some measurements and metrics around there, some SLOs that you're trying to say, like, these dashboards are going to be ready, available for everyone to use. The ad hoc reporting sometimes suffers because it's resource bound. I mean, you have a certain number of resources that you're using to do all your processing. And then when it comes to the actual ad hoc reporting piece, there are people that have ideas. They want to try and start looking at things. They're using visualization tools and this kind of stuff. And yeah, essentially what they need is more data. They need visualization tools. And they need access to historical data. So all of this requires, we have enough storage to store the data, we have enough capacity to run those kind of processing, and we can support all the different types of tools that they want to use. So the next one is ad hoc analysis. This is kind of the data science area, the statistical area where people are actually going in there. They're trying to work out, what's this new trend? What's this thing that I'm looking at? Why have I got some country, for example, that's underperforming in sales? It's been doing well all the time, and now suddenly it's underperforming. What caused that? And again, what we need here is, strong tools to be able to do this. Again, capacity comes up. If you don't have the capacity, then these types of questions sometimes get put in second place because the other things have been prioritized. And the last one, operational insight. This is operationalized insight, I should say. I knew it was going to be a tongue twister. This is really where everyone wants to be. This is the place where essentially you've done all this analysis work and you're using it to predict the future. So you're using it to work out, for example, here, I'm trying to work out how much fuel I need or how much I should purchase for the next quarter. I'm using these numbers to actually drive those decisions. This is a decision-making space. Again, some of the challenges in this area, predictive capabilities, like what kind of tools, what kind of frameworks do you want to support, diverse data sources. Again, data's coming from all different places. Some of it can be stored easily in the data warehouse. Some of it's in the data lake or maybe not even available. And again, having enough capacity to run this stuff. So I'm going to make some very gross generalizations. But what we see when we're working with customers, and again, these are generalizations, so they might not be specific to you. But some of the stuff that we see, for example, is that a lot of work is being done, and a lot of people start from the operational reporting side. They want to move to that operationalized insight, but there's a lot of stuff that has to be done to get them there, and they don't want to sacrifice all the work that they've done to have the operational reporting in place. So if we're going to migrate the data warehouse, we can say, oh, great, now we can do this, we can run some machine learning models, and we can take that output and we can make it available so we can do some kind of recommendation system, for example. But if they can't support the reports and the dashboards that they've been relying on, then they're like, well, first we need to solve that. That's what we see coming, time again. And we see often, a lot of customers, when they're working with their stuff, on-premise, they struggle for resources. There's a finite number of resources that they have, and those resources are, there's a lot of claim on those resources. So, there's a good reason for them to move to the cloud, because we can, give them more and more resources to use. We don't have those same constraints. But yeah, hopefully that gives some indication of the reasons why we would do this. So as another kind of generalization, this is the kind of movement we see. We see people starting with operational reporting, with ad hoc reporting, and moving up into that operationalized insight. And of course, a lot of that operationalized insight is based off the ad hoc analysis as well. Building out those machine learning models or other prediction models to actually take you to that place where you can start putting this into some kind of process to actually make decisions. So, obviously, no slide deck is complete without Maslow's pyramid. So here's a best attempt at something very colorful. What we've basically got here is if you look at each level, this is, to get to that top piece, this is the kind of stuff that is built on. So we've got data quality, data timeliness right there at the bottom. We've got the capacity and the tooling. You need all of these things to be able to fulfill your different use cases. So this is what your platform should be providing. Okay, so why do people, why do folks actually consider migrating their data warehouse in the first place? Well, obviously I've just been through some of them, but just to kind of recap, cost of infrastructure, not having enough resources. Another one that we see is there are specific skill sets that you need to run some of these systems. So for example, let's say you're running Hive on Hadoop. You might have a whole team that's actually required just to support that Hive installation. And that might not be core to their business. So you're thinking, hang on, I don't mind having 1 or 2 people doing this, but having a whole team, I could have that team doing something else. So these are things to think about. And some of the stuff that kind of limits there as well are things like upgrades. So I'm sure some of you went to the Dataproc talk yesterday, and you would have seen, for example, it's very easy in the cloud to run different versions of Hadoop. Whereas when you're on premise and you need to update because you're missing some capability, that might mean shutting off the cluster, actually performing the update, and if it doesn't go well, rolling back. So you have this kind of, this game that you have to play to actually give that capability that you're trying to offer to your end users. And concurrency often suffers as well. A lot of these systems have the kind of performance that you require to actually run the query, but when it comes to many users asking, questions at the same time, there is some trade-off in concurrency there. So Google Cloud's data warehouse. I'm just going to take a sip of water. That's always good for YouTube. So Google Cloud's data warehouse. Well, BigQuery, as you know, that's why you're here, obviously. I probably don't need to tell you any of these things because you've probably already been looking at BigQuery and you're thinking, yeah, that's great, I know BigQuery. But just for anyone that hasn't seen it, these are some of the things that we call out on BigQuery for the reasons why customers are going to move. Later, I'll look at some of the newer features that have been mentioned today. But some of the important ones here, and I think like the most crucial, when you're migrating a data warehouse, it's like, can I use the skills that I already have? So standard SQL, that's a hugely important one. Can it cope with the amount of data and the concurrency that I need to actually, get the benefits that everyone's able to perform their analysis, that I can run all these different types of reports. And security here, so the encryption, we have default encryption on all of our storage. You can choose to bring your own encryption keys. So for particularly sensitive workloads, managing your own encryption keys might be a good thing for you to be able to do. That's particularly important in something like the finance sector with certain data. And then, highly available, managed, that you don't have to focus on the operation of BigQuery. You can actually focus on using BigQuery and actually creating your use cases. So very high-level architecture. This is what BigQuery looks like. There are a number of parts, but I will try and break it down. So storage is separated from compute. This is common across all of Google products. We'll see it a little bit more in a moment. That petabit network in between is actually 1.3 petabits. There's something like 130,000 machines talking at 10 gigabits per second. What that essentially means is that we can have our compute disaggregated from our storage. We can grow either one independently. We can serve multiple queries from the same storage. We can, for example, if you were trying to create your own data warehouse using Hive and Parquet and Hadoop, for example, you would have to make some choices as you grow that cluster. There is a ratio of CPU and memory that you attach to those disks that you're making available. And obviously, you can optimize. You can say, I'm going to have bigger disks and fewer CPUs, or the other way around. But you still need to think about that. They're not separate. Here they are. And that's really possible because of the network in between and how fast that is. Other things which are very important here is that we have, on the right-hand side, standard SQL, so everyone can use a language which is common to them. And on the left-hand side, we support both batch and streaming data. So you can have a table with, like a petabyte of data in that table, and you can still be streaming in the latest updates. And you can query over both of those in the same query. So you can have a query which is basically running and giving you, the context between what's happening now and the historical data from running a SQL query. So this is not unique to BigQuery, that separation. This is across all of our products. So if you look at the bottom here, these are all the different types of storage. I have a storage session this afternoon if you want to know more about that. But the different types of storage, for example, I'll call a few out here. So BigQuery is columnar storage. So Dremel was the original white paper. We now call that capacitor. It's like an evolution from there. To give you an idea, storage formats like Parquet are actually based off of Dremel. So Bigtable, its key value is column family. It's really good for random reads and writes. Sometimes you might want to query that with SQL. Well, that's possible through BigQuery doing federation. You can also, let's say you had a data lake and you've got Avro files, CSV files, awk files, Parquet files, JSON files, and you don't want to load those yet into BigQuery for some reason. You can have them available on Google Cloud Storage, and you can run federated queries over them as well. So some of them you can do federated queries, and others you have to load through a job. But CSV, Avro, and JSON all support the federated query model. So you have different options available to you here. I mean, obviously, if you want to get the best native performance of BigQuery, then the columnar storage is obviously suited for running, analytical queries. That's why that storage exists. But this gives you an idea. And the same data that you're storing in BigQuery, maybe you need to make available to your machine learning algorithms for training. So you'd have at the top there Cloud ML Engine, which can access BigQuery and actually pull from that data storage to actually go and train its model. So it's really about thinking about which storage fits and what type of processing fits. So on the top, if it's BigQuery, it's SQL. On the bottom, if it's BigQuery, it's columnar storage. On the bottom, if you have a random read-write use case, you would think about something like Bigtable. If you wanted to run some federated ad hoc queries of that, you could use BigQuery. If you wanted to have the column of performance, then you would use something like Dataflow to take that BigQuery data, that Bigtable data, and load it into BigQuery so you get a benefit from the high performance. And if you need both types of access, so the high analytical performance and the random read-write stuff, use 2 types of storage. Just make sure the pipelines feeding that are idempotent, functional, so that you can reload it and have a consistent output. We will look a little bit about that in the demo in a moment. So moving on here, this is one of our customers. I'll let you read this yourselves, but this is basically, well, let me bring up the big one. The reason for doing this together with us is that we work on providing this as a managed service, and you work on your use cases. The more we can do that, the more we can have a successful partnership together, where we have our engineering focused on bringing capabilities, and you have your engineering focused on using those capabilities to do cool stuff with it. So I'm going to move very quickly to the reference architectures. This first reference architecture, let me go back a slide. This is OK, I'm going to do a migration now. Where do I start? So obviously, you don't jump and say, right, click your fingers and the migration is done. Migrations are complex. This is the first setup that we like to advocate. So on the left-hand side, we've basically got your current on-prem situation. This may look like what you're running on-prem. It may not. But to give you some idea, this is kind of like, you have your source systems. You have some kind of ETL process, which loads that data into staging, runs, does some transformation, maybe denormalization, dimensionalizes that data, makes it available in a data warehouse, and there's a whole bunch of reports and use cases that are taking advantage of that data there. And the orchestration piece in the middle, that's basically allowing you to do all of that, making sure that happens every day, making sure things happen in the right order. So in the first move that we're going to look at in the demo in a moment is actually a mirroring. So we will read from the current data warehouse, and our goal will be, in the first instance, is to have the same available in BigQuery. Now, once it's available in BigQuery, you can start denormalizing some of that data, aggregating some of that data to make it available for use cases, so for new reporting use cases. We're going to use Data Studio here, but there's a whole bunch of tools out there from partners that you can use for the reporting, as for the ETL as well, but we'll come on to that in a moment. So the piece that we're going to look at here is what do we need to do to be able to mirror the data warehouse onto BigQuery? And to kind of recap why we're doing this, we want to get results fast. We want to have the least amount of risk to our business. We're selling them on quite a big thing, so we don't want to say, look, go ahead and do this, and then once you've done it, we will see how long it takes. No, let's take a route where we can do some of this, show them how good it works for them, show them what they get out of it. Don't put their current process at risk. And once that works, then we can move on to the next phase. And we also get GCP adoption. There are many people that haven't used all the GCP tools, maybe in your business, other developers, other analysts, other business users, and they get from this the opportunity to start working with those tools. And importantly, we can benchmark stuff. Numbers talk. So we can actually show to any of our stakeholders, look, we were running these queries here before, it was taking this much, or we had this kind of concurrency, we could only support this number of users, and now we can do this. So you get that from this first architecture. What's the target? Well, we don't want to go from running one data warehouse to running 2 data warehouses. The whole idea is to do this migration. So the target is obviously to actually have the full data warehouse process running on GCP and reading from those sources. Now, those sources might be on GCP, they might be on-prem, they could be on another cloud provider, but essentially for this particular migration, what we're looking at is taking that data from wherever those sources may be and doing the ETL process, doing the data warehouse process on Google Cloud. And that's what we're going to look at in the demo, so both those stages. So with that, I'm going to hand over to Ashok for the demo section.
Thanks, Rob. All right, let's get into it. So today we'll look at what it takes to do the migration to GCP. And in this first stage, we'll look at the mirroring the data warehouse to BigQuery. And we'll start with the data already landed in Google Cloud Storage. So I'll be doing a lot of back and forth switching because of the slides and demo. OK. So what we've done is we are mirroring on-prem data warehouse, right? So we already have the facts and dimension data. And since facts are usually larger in size, we have to organize them by date. And let's take a look at the fact data here. So they are organized by date. And if something goes wrong or you update your on-prem data warehouse, all you do is just reload the partition, right? And in BigQuery, we are going to store this as a partition table. And dimensions are usually small, so you don't really have to partition them, and it's OK to basically refresh all the dimension data every day. And this also ensures that any slowly changing dimension techniques that you've employed would just carry over to the data warehouse as well. And this is how the dimension data looks for the demo. And for the demo, I'm using TPC DS data just to get a data warehouse set up. So 1 second. Yeah, I need to get a hang of the switching here. OK, so we looked at the data sets. So what we're doing is we're going to stage the data in Google Cloud Storage, facts organized by date and dimensions in just a folder. We're going to do a refresh every day. And then we're going to use Cloud Composer to basically orchestrate this workflow and materialize the table in BigQuery native format. Once that is done, what we'll do is we'll run some downstream aggregation queries. We can materialize that as well. And it's always a good practice to materialize aggregation queries that are frequently used so that your reports are not laggy, right, due to runtime calculations, and also the data is not open for interpretation. All right, so let's take a look at that. OK. So what we're trying to do is we're trying to get to this report, right? So this report is basically calculating cumulative sales and returns per sales channel. And below, we're seeing a scatter plot of net sales by different channels. So how do we get there? So as I said, we are using Cloud Composer to basically orchestrate this workflow. So we are seeing here is on the left, we are creating staging tables. So we are basically creating a federated BigQuery table, which is pointing to a file in Google Cloud Storage. And then we materialize that into a native BigQuery table. And once that is done, we do the same thing with fact tables. But it may so happen that you probably have to replay a partition, right? Because you've updated something on-prem, so you have to replay the partition for your fact data. So what we've done is basically we've added a Boolean variable in the Airflow code to basically just load fact data and not dimension data. So in this way, you have a repeatable idempotent process for loading fact data. And this is a code that does just that. Right, so all I'm doing is, so this is an Airflow variable, which I've defined up here. And then if it is yes, then we load dimension and staging. If it is no, we just load the dimension. Right, so let me just trigger this, and then I'll walk you through the individual processes. So I'm going to trigger it for today. So let's just quickly check if the variable is set for today. It is yes, 25th. So I'm going to go back and trigger the table, trigger the DAG. All right, so it is running. So let's just go back there. OK, so I spoke about external tables being used for staging purpose and Google Cloud Storage being the staging area. Let's take a look at the definition of those. So the dimension table, as I said, is refreshed daily. So it's just pointing to a location in Google Cloud Storage without any date-based partitions. And the fact tables are partitioned by date. Hence, they are stored in a date folder. So it is today, right? And for materializing those tables from the staging area into BigQuery native, all we're doing is just a simple select star into a table. But then you could obviously get creative and then add your own transformations or do further denormalization if needed. The aggregation query that I'm using is a simple query that aggregates all the sales and returns by 3 different channels. There's sales, there's store, web, and catalog channels. And I'm just doing a cumulative sales and return, just a summation on all the 3 up to today. Let's take a look at the DAG if it's finished. So it's still running. We'll give it a minute. Okay, so as you can see, the staging areas have been created, and then they have been materialized. Now we are at the stage where we're trying to materialize fact. That is done as well, so it's success. Now it's the last stage where we are materializing the aggregation query as well. So once this is done, we should be able to see a partition in the sales by channel table, which I created for materializing the aggregation query, and this is done as well. Let's take a look at the partition. So I'm querying the partition summary metadata for that particular table. And if I run this query, I should see a partition here, so as you can see. So for 25, which was created just now. Now if I go to the report, I should be able to see the report being updated for today. There you go. So that's demo 1, where we mirrored the on-prem data warehouse to Google Cloud Storage. Now let's take a look. Okay, I need to switch. Oops, sorry about that. Okay, so let's take a look at demo 2, wherein we've done the cutoff, right? So the end state is we are running the data warehouse in Google Cloud Storage, and what does it take to make that functional? Okay, so this workflow looks quite similar to what we had earlier, but there's a significant difference. We are partitioning dimensions as well. Now it's obvious why we partition facts, because they're large, and I've spoken about that. But why dimensions? Number 1, to keep the whole workflow simple and easy to maintain, and we have a reproducible and idempotent process as far as the data pipeline is concerned. And also because SCDs are cumbersome, right? Slowly changing dimensions are cumbersome and can get easily complicated. With this, what you can do is you're just doing a refresh of your everyday dimension data into a new partition in BigQuery. This gives you bitemporality, easy to implement bitemporality. You can go back in time and look at the state of your data at that point in time by just querying a particular partition in dimension. So you don't have to create complex joins, or you don't have to have complex ETL processes to maintain. So that's why we are partitioning dimension data as well. So this is part of the functional data engineering approach which we have taken here. And the fact is the fact data is partitioned by event date, and the dimension data is partitioned by the processing date when you process this. Okay. So I'm going to switch back here and go to my second demo. So I said that dimension and fact are both partitioned once you do a cutoff. Let's take a look at the dimension data. So it is, in fact, partitioned by date. Let's take a look at the DAG that supports this whole workflow. So it's similar to the one that we had earlier. We are creating staging tables, doing a federated, creating a federated table in BigQuery for both dimension and fact. We are materializing dimension data. So note that we are using TPC-E specification data, which is in third normal form. So obviously, we have to create facts and dimension data when we materialize in BigQuery. So this task is doing just that. It is materializing the dimension data. Once that is done, we are going to materialize the fact data, and that will be the end of this workflow. So let me just trigger this and then walk you through the whole process. Okay. So that's triggered. Now let's take a look at the various queries. So I said that the dimension and fact tables are both organized by date. So this is a fact table, trade. It's organized by date. And let's take a look at the company table, which is the dimension data. It's also organized by date in the staging area. And the queries that I'm using to materialize these tables into BigQuery are simple joins. So basically, I'm denormalizing the data. This is for trade, and I'm basically joining that with status type and trade type. And for company, I'm basically joining that with status type and address. Right? So you could actually use any ETL process, any ETL tool of your choice to do this. But in this case, I'm just using SQL and the staging area being Google Cloud Storage. But one thing to note is that For company, which is a dimension table, we are having a partition date, which is called the created date here, and we are partitioning based on that date, which is the day when you run the workflow. And for trade, which is a fact data, we are basically partitioning by the event date, which is t_DTS in this example. Let's also take a look at one of the queries that we'll be running after the DAG completes. So in the previous example, we saw how we could create, we could materialize a query and then create a report on top of it. But BigQuery can also be used for ad hoc analysis. And this query is basically calculating the 60-second simple moving average on bid prices in a 3-hour period for all the securities that just get loaded once the DAG completes. Let's take a look at the DAG if it is completed. It's running. It'll be done soon. Okay, so the materialization of dimensions is complete. Now the next stage is basically materialization of the fact table, which is trade. And once that is done, we'll run our moving average query. It's running. It'll happen. So what I'm doing here is I'm deleting. So basically, we are creating a staging table, right? So the files are in Google Cloud Storage, and we are creating a federated table. So obviously, every day when you run, you have to point that table to the right file in Google Cloud Storage. So hence, the first step is to basically delete the table definition and then recreate it with the file for that day. So that is what this stage does. So now the create stage table is done. It's a success. Now finally what we're doing is we're going to run the query that I showed earlier, the denormalization query, which joins trade table with address and status type, and then creates the fact table in BigQuery. So it should be done in a few seconds here. And that's done. So let's go and run our query here for today, which is a moving average, a 60-second moving average over a 3-hour period for all the securities. And there you go. So it just ran, and we have all the moving averages. So BigQuery can be used for ad hoc analysis as well. And that completes the end-to-end workflow. So for when you do a complete cutoff. Now let's look at another interesting concept in BigQuery. So far, we've seen a functional data engineering approach where we create repeatable and idempotent processes, and we basically replay the workflow and then update the partitions, right? So we don't do any DML statements. But DMLs can be friendly when used in the right format and the right way. And when you do a DML update, you update a large chunk of data in BigQuery. But what if something goes wrong? So how do you recover from it? So we're going to take a look at that exactly now. So what I'm showing here is a query that basically queries the trade table that we just loaded, and for a particular customer ID 472. So let's take a look as to what the data looks like. Now let's say that I want to update this trade table for this particular customer for a particular security. But what I did instead is I just updated all the I updated the commission column for all the rows for that particular customer. So that's obviously an error. So I realized that I made a mistake. So how do I recover from this? So there are two options, ideally. The first option is go back in time. All you have to do is just replay your workflow with your partition date equals 22 in this case, right? So July 22. And then you just override the partition and then move on from there. Or you could use BigQuery snapshots. Right, so BigQuery snapshots are automatically created and maintained for you for 7 days, and then you can go back in time and then get the state of your table at that point in time. So we're going to use BigQuery snapshots and DML to recover from this error. But before we do that, let's take a look at what the status of the table is after the update. So what I did is I updated the commission column with equals to $45 for all the rows for that particular customer. So this is how it looks like. Let's look at the BigQuery snapshot. So how it was 5 minutes ago, right, before I did my update. So as you can see, the securities have the right commission values. Now we're going to use that and create a temporary table, which we are going to then use and do an update join on the trade table that we erroneously updated. So the temporary table is created. Now I'm going to run an update join with the temporary table and my trade table for the for the partition that I just messed up. Okay, so that's done. So what it did is it basically updated all my customer rows for customer equals 472 from my BigQuery snapshot, the temporary table that I just created from it. Let's take a look at how the data looks like after correction. So it should be similar to what we looked in the BigQuery snapshot, and it is not $45. Now we can just go back and update for the security that we really intended to update. It's done, and then we'll just see how it looks like once it's updated. So all good. So no backlashes there, right? So that's the end of the demo. Before I hand it off to Robert, I'm going to quickly talk about various ways to ingest data into GCP. So we've looked at using Google Cloud Storage as the staging area. So you can use GSUtil and the storage transfer service or the data transfer service that comes native to Google to ingest data into GCP. But there are a plethora of partner products as well, which you can use. And you might already be using these today in your existing toolkit. And it's an easy switch to basically migrate data from your on-prem systems or your source systems into GCP. Over to you, Rob.
Thank you, Ashok. So hopefully that kind of showed you how easy some of this stuff can be. I mean, we saw two approaches. We saw the functional engineering approach, overwriting partitions, keeping things idempotent and repeatable. And as Ashok demonstrated in the last piece, if you do have DML statements that you're going to run over multiple days, over a very large table, you have the BigQuery basically time travel functionality for the last 7 days to actually go back and restore. So that will hopefully help you in some of this work that you're going to do. And again, BigQuery is it's the crown jewels of our data products, and it really sits there in the middle and in a huge ecosystem. These are some of the partners for the integration. There's a whole bunch of partners as well for reporting and everything else. So it's really, depending on how you want to approach this, you're in good hands. So let me just, for anyone that missed any of these things, some of the new product features. You saw throughout this demo today the new BigQuery UI. You can already go and use that. So for those of you who are saying, hey, the BigQuery UI looks different. What's this new thing up here? This is not BigQuery. That's the new UI. This morning you heard about BQML. So these are other things that you can start to do once you're operating in BigQuery. We got partitioning at the moment, so you can do partitioning on the insertion date, or you can choose your own date column. As we saw here with two different examples of partitioning. We saw an example where we were actually partitioning on a logical date, because for our fact table, that fact data, we expect it to be quite large, and we just want to have the ability to replay the events or the transactions for a given day. And in the second use case with the dimension data, I mean, even if your dimension data is millions of rows, I mean, if you think about that in context of BigQuery and these kind of systems that you can use, just replaying that again and having a new snapshot each day really helps you overcome some of those slowly changing dimension properties. So you have the partitioning we're using there was basically on a date, which was the insertion date. Available now is clustering in beta. So if you can imagine what clustering, basically you partition first on date, and then you would have some other column with a high cardinality, which you basically cluster on. So again, we're reducing the amount of data that we need to pick up in that initial scan, which is going to make the query cheaper to run, faster to run. So if you have good use cases for this, so think about, first of all, you're joining or filtering by date, and then you're joining or filtering by something else. This would be a good feature to actually go and explore. Something we didn't show here, but Data Studio Explorer is basically going from BigQuery and clicking and actually being able to see the results of that query directly in Data Studio. There are deeper integrations with Sheets. So just making the whole experience using your data in BigQuery available for end users who are using Google Sheets. And later this afternoon, 3:15, if you're not coming to my storage talk, obviously, then there's a nice talk about GSI data as well, which is amazing. Some really great demos to go and see there. I'm really excited about that. Actually, I might just miss my own talk and go and watch that one. So we've gone through quite a lot today, but what I want to kind of hand this off is like, so we've gone through some of the reasons why and what we can do with this. We've gone through an approach, how we could do that, first the mirroring, and then the full process running on GCP. And this last part is really kind of like, okay, this is all great, but how do I organize myself together with Google and together with partners to actually go and do this migration? So we put together a playbook which we think is kind of, would help kind of illustrate how to do this. So these are the different stages of the playbook. So first of all is documenting the current state, understanding exactly what it is that you have. The next thing is outlining the experiment, and we'll come on to why we do an experiment. Getting resources lined up, like you can't do this by yourself. I mean, you can. It might just be one of you, and it's just your data warehouse. But typically, there are many, many people involved, stakeholders, end users, other teams. So all those resources need to be lined up. How do we go about committing and executing this? And importantly, once we've gone through this cycle, showing the end users, getting everyone excited about the stuff, and then repeating it for the next bit. I guess you could call it some kind of agile process, no? Yeah, I'm going to go through each of these stages now. So document the current state. I'll go briefly through this. Why are we here? Like, what are we actually trying to accomplish? Like, we're not just migrating for the sake of migrating. There should be goals that we have, and we should be able to articulate them. Where are we coming from? Get the whiteboard out, get all the people that are involved from the different teams, actually explaining where you're coming from. Explain it to us, explain it to the partner as well. Like, if we understand where you're coming from, why you've made certain decisions, we can take those learnings into the migration, into the new thing. If we don't know about those things, and we is all of us in this case, so the people that are building this, the partners, all of us, if we don't know about those things because someone forgot to tell us, then we're going to go and discover those later. And that will be, somewhere down the line after the migration or during the migration when data doesn't look exactly the same. And then someone will say, well, actually, I decided to do it like this before. So it's really important to understand that stuff. And find out, get feedback from everyone involved. What's already working well? Nobody likes, having a new solution put in place and they're saying, hey, this is great, but it works better over here. That's just not the place you want to be. And what's not working well? Because this will also help you already start to win hearts and minds of people. You say, well, this piece isn't really working well. So if we maybe explore some of that, we can already get some people, who are standing around the water cooler, talking about, oh, great, we've actually solved this problem that we had for a long time. So outlining an experiment. This is really kind of digging into that piece of the documentation and trying to understand what it is, what's the one piece that we're going to take from, let's say, from all the possible things that we're going to go and do for this first one, this next one, what is it we're trying to do? So what's possible? What are the constraints? What is the value to the business? Things like in the initial use cases, as I said, this is an iteration, but in those initial use cases, think about smaller things, Get some experience. I know I just mentioned that there's this problem that you want to solve, but if you can already get a quick win and just get everyone's hands kind of accustomed to what you're doing, that next bigger problem is going to already seem a lot easier. For example, there are things that you should be considering along the way. You should be asking us questions. An example. I once got handed a project which was all of the ad data, and it was a lot for the company I was working with, being imported on-premise because that's how they did it. They didn't have the processing power on-premise, so they uploaded it into the cloud. They ran a Hadoop job on that data. They then pulled it back and they put it into the data warehouse, at that time was SQL Server. We were migrating to BigQuery. We looked at this and we said, hang on a second, do we need to set up this ETL process? And there was a data transfer service available, which put the data straight into BigQuery. Now, that's great if you're working with, some GA data or ad data, which is already available for you in that way. that data might not be there. But there are also, as we mentioned before, partners that are working on this data as well. So if you've got sources which other people are using, so our market data, Salesforce data, all these things, think about are there already solutions out there for that? That's just keeping everyone alert, making sure that we do useful things. Define the time frame, the requirements, all this kind of stuff, and sketch out an architecture for the experiment and try to make sure that everyone is aligned. I realize some of this really speaks to itself, but sometimes just going through it with everyone is really useful in getting everyone aligned. Lining up the resources. So there are a number of people involved in this. There's the customer, there's a partner, there's Google, and there are others as well. We may have analysts in a specific domain. We may have consultants that have done this before that we're bringing in to work with us. It's really important to understand who these people are, what role they are, because another thing that we see that happens is we start a migration. We're like, OK, we've got this team. They're going to do a migration. And suddenly there's this reason, like, for example, we don't have a partner in place to actually help us and give us the breadth that we need. Or we don't have one of the data experts in place, and we don't actually understand the stuff that we're now migrating. And we started the migration, and now we're like 3 weeks, and we've got a block, and that person's on holiday, and now we have to wait. And it's fun and games. So making sure that we understand the resources and who they are and getting them lined up timely for this is really important as well to be successful. Commit and execute. So there are some things here you need to think about: security, data locality, the cost, licensing. If there may be some of the stuff you want to use, the third-party stuff from partners, and you need to bring your own license, for example. So think about all these things, and when you're about to execute on this, make sure that anything that we execute on addresses those concerns. Otherwise, we go for another iteration where everyone kind of standing around saying, hey, but the security doesn't live up to what I want. The security is going to be really good, but we need to make sure everyone understands that the security is going to be really good and has had their chance to explore that and get information about it. And the next thing, you've just delivered an MVP. Show everyone. Get everyone excited. Let them see that it solves their use case. And then get the next one lined up and reiterate. And just keep doing this until everything's migrated, and you'll be happy. Your end users will be happy. And you'll be asking for new product features on BigQuery. So that's it. I'm going to leave you actually on this slide, which is some things for you to go and get started, check out, try out. These are all small links, so you can just go and click on them. There's about the data journey. There's GCP free. There's some architecture stuff there as well.